Good morning, students. Today we are starting over the new chapter, that is gravitation. Let me try to explain to you regarding the difference between gravity and gravitation. Now, gravitation is a force of attraction between any two objects in the universe. Okay, gravitation is nothing but it's a force of attraction between any two objects in the universe. Now, what is gravity then? Gravity is nothing but it's a force of attraction between the earth and any other object. Okay, it is nothing but it's a force of attraction between the earth and any other object. Earth and the object. Here, when I'm talking about gravity, I'm being very specific. But whereas when it comes to gravitation, I say that it's nothing but it's a force of attraction between any two objects in the universe. So, if you have understood these two terms, we will move on to the next concept. Okay, that is nothing but the centripetal force. Now, centripetal force is very, very important. Now, what is the centripetal force? Centripetal force is also known as the center-seeking force. For example, when I tie the stone to a thread and when I try to spin it, we see that the stone is getting pulled towards its center. Okay, this is nothing but the centripetal force. Now, centripetal force is a type of a gravitational force. Now, this centripetal force is responsible for the planets to move about the sun as well as for the moon to move about the earth. If centripetal force, suppose if it was not there, what would have happened? Then we see that objects would have moved in a straight line. So, you can just try to understand how important this centripetal force is. Okay, now let's try to derive the formula for the universal law of gravitation. Now, what is this universal law of gravitation? Now, according to universal law of gravitation, we see that the force between any two objects, okay, the force between any two objects is directly proportional to the product of their mass. So, force between any two objects is directly proportional to the product of their mass and inversely proportional to the square of the distance between them. Suppose I take two objects, okay. So, this is M1 and this is M2. Now, the distance between them is D. Now, according to the universal law of gravitation, what is it telling us? It is telling us that force of attraction between these two objects is directly proportional to the product of their mass. So, it means more the force, okay, more the mass, more will be the force of attraction. Okay, so if one factor is increasing, the other factor will also increase. So, and it is inversely proportional to the square of the distance between them. It means that if one of the factor is increasing, the other will decrease. Suppose if the distance is more, then the force of attraction between the two objects will decrease. More the distance, less will be the force. So, one factor is increasing, the other will decrease. So, this is with respect to the universal law of gravitation. Now, I can also combine this and write it accordingly. So, this is how I combine and write it. Now, students, here there is proportionality sign. I can introduce a constant here now. So, I am removing this proportionality sign and putting equals, equal to, and this proportionality is introduced by this particular constant. This is known as G. G is known as universal gravitational constant. Okay, G is nothing but universal gravitational constant. and its value is found to be 6.67 into 10 to the power of minus 11 Newton meter square per kg square. So this is the value of G. Students, the SI unit of G is Newton meter square per kg square. Now let's try to understand how exactly did I derive this particular SI unit. So we know F is equal to G M1 into M2 divided by D square. Okay. Now F is nothing but the force of attraction. It's given by force of attraction. Now I want to find out the unit of G. So what do I do? Now I'm taking the D square to the other end. Okay, then I'm getting M1 into M2 down. So what is the unit of F? F is nothing but force. So it is given by Newton. D square is nothing but, it's the unit of distance, which is nothing but meter. Since it is D square, it will be meter square. Okay, and M1, okay, it is nothing but mass. The unit of mass is nothing but kg. But since I have, there is M1 and M2. So this is also kg, this is also kg. So it will become kg square. Now when I take this on top, it will become Newton meter square per kg square. So this is how this is by means of which I derive the unit of G. Hope you have understood. Now next concept that you need to understand is free fall. Now free fall is nothing but object is falling towards the earth only under the influence of the gravitational force. So I'll repeat it once again. An object is falling towards the earth only under the influence of the gravitational force alone is known as free fall. Acceleration due to gravity. Now the symbol that is used to represent acceleration due to gravity is small g. Now students, there is difference between the symbol capital G and small g. Now the capital G is used for universal gravitational constant. Okay, but whereas small g is used for acceleration due to gravity. So whenever you are representing, you need to be very careful. Now the acceleration due to gravity, the value is 9.8 meter per second square. Now what is this acceleration due to gravity? It is nothing but when an object is falling towards the earth, okay, it is under acceleration. And this acceleration is because of the earth's gravitational pull. This is nothing but the acceleration due to gravity. Now let's try to derive the formula for acceleration due to gravity. Now there's an object that is falling from top towards the earth's gravitational force. Let the mass of the earth be capital M. The mass of the object, let it be represented by small m. The distance between the two is given by d. Now we know according to the universal gravitational law that each and every object in the universe attracts each other. So the force of attraction between the object and the earth is given by this particular formula. Okay, the formula is F is equal to G capital M small m divided by D square. Now we know F is equal to MA. Now I can substitute this A with G because I'm talking with respect to acceleration due to gravity. So that's why I can also write it as mg. Now instead of writing F force over here, I can write it as mg is equal to, I write this particular formula over here. Now which is a common factor that I can cancel out, that is small m I can cancel out. I am left out this with this particular representation. Okay, so G, acceleration due to gravity, is equal to universal gravitational constant, mass of the earth divided by distance square. Here, by looking at this formula, what we can understand is acceleration due to gravity is not dependent upon the mass of the object. Now, what do I mean by this? Let's try to understand with the help of an example. Suppose I throw a stone and a paper ball from a height. Now, which one will take less time to reach? It is definitely the stone. Suppose students, if I remove all the air which is offering resistance, then if I drop the stone and the paper ball at the same time, it will reach at the same time below. Okay, why? Because acceleration due to gravity is not dependent upon the mass of the object. Hopefully this is clear to you, the example. Now let's try to derive the units for this. Okay, now this is a formula for acceleration due to gravity. We know G is equal to Newton meter square per kg square. The mass is given by the SI unit kg divided by distance square. The unit of distance is meter, so it is distance square. So I take it as meter square over here. I cancel out meter square and meter square. I am left out with Newton per kg square, okay, into kg. Now Newton, I can split it up and write it as mass into acceleration. The unit of mass is kg, meter per second square. Now I write this particular unit over here. So kg meter per second square into kg per square into kg. So here what happens is the kg gets cancelled. Okay. So here the unit that I am left out with is meter per second square.